What's up, AP Calculus? This is Mr. Sindel. I'm recording this kind of late-ish, and I'm maybe a little bit quiet, so the sound quality is going to be This is final exam number 3 review. Thursday. We're almost done. We have 2 more of these left officially. So let's jump right into it. I don't have my my adapter to talk to my stylus and my tablet, so I'm going to do this in Word, and we're going to see how this works, so bear with me. I've taken the liberty of labeling these pieces, -8, 3, and -2, that came from down here. If it's negative, it's below the x-axis, or vice versa. If it's below the x-axis, it's negative. The other thing to keep in mind is that we do have horizontal tangents here between at 1 and at 4. So it's like the graph appears, which is slightly different than the final. I had to correct some things, as I already said before. All right, so farthest to the left. Let's go ahead and just, insert a table. Boom. We need some values of t. We need, I want this all to be times New Roman. Okay. We need a start plus change, and we need an end. I would like these to be centered. And what do we need to have for our first start time t? And the answer is we need whatever our start interval is. Why is the table not letting me? I'm just going to go with it. We need to have 0, and we need to have something. We definitely need an end value. I can add more rows in here if I need them. Our end value is 6. That's just the bounds of the graph. We also need other t values that are critical values, or CVs, aka where does f prime, v in this case, where does that cross the t axis? And you can see 3 and 5 should be in here. And yeah, you could put 3 and 5, but we can be smart about that really quickly and save us some work in the long run. If we're looking for the particle farthest to the left, that means we're looking for a minimum, which means we're looking for a critical value that is preceded by negative area, which 3 is a good one. However, 5 is a bad one because it's preceded by this positive area that's clearly not going to be the answer. 6, though, I mean, it's already on our table, but it might be. You can see it's not because the 3 outweighs the -2, but you still have to consider it because it's so close. In fact, in the grading scheme, you get a point for calculating what happens at time is equal to 6. But we do want to have the critical value here of 3. All right, so our start tells us we got -2 for our start, so I'll say -2 plus we have the integral from, I guess, 0 to 0, kind of silly, of the velocity. I can say dt. Being formal about it, might as well. It's a free response question after all. So our end value is going to be -2 plus 0, which is -2. Great. What about down here? In fact, I'm just going to, be lazy because I have technology. Just going to copy, paste, copy, paste, copy, paste. And I am running out of room. Hopefully that'll be okay. I can make all this stuff smaller. The end interval is going to be 3 here and 6 there. Okay, we have all that set up. What does this actually equal, though? So obviously we have the -2 plus something. So from 0 to 3, graphically, we just, subtract 8. So -2 minus 8, and that is -10. Cool. What about this one? If I start with my -2, I'm going to go add 3 and go to -2. So it's going to be plus 3 minus 2. What is that going to be? Oh, I forgot the -8, didn't I? There we go. -8 plus 3 minus 2. That's all 3 of these on top of the start condition, and that's going to be blah, 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 -9. Yeah, that's right. You can see -9, -10. We're really close, which is why I wanted you to calculate that other value. So the correct answer here is -10. That's the farthest to the left. We need to have a conclusion, and I ran out of room, so let me, make this smaller. Yeah, that's good. Let me type right here. So farthest to the left at time at t equal to 3, and we can say at position -10. Cool. Part B. For how many values of t between 0 and 6, the whole interval, is the particle at x equals -8? This is a hard question. This is, I think, probably the hardest question out of all 4 of these, in my opinion, because it's not super apparent. But check this out. Look at the end position here and the end position here. This function is continuous. Why? Well, I mean, the graph of v is continuous, therefore the position must be also continuous. I don't have any like sudden jerks in velocity. I don't like jump from here to here. That could mean we have something weird happening with position as well. But v is continuous, position must be continuous. So down here, if I'm continuously moving from -2 to -10, in between -2 and -10 is -8. So it happens at least somewhere in between 0 and 3. The problem is we don't know at what time. We just know that it happens, and that's what it's asking for. How many times? Well, at least once in between there and there. And you might say, okay, -9, -10, not in between there and there. There's no -8. But remember, we skipped a value. We skipped this critical value of 5, which we should have added. So I think this is how I would approach the problem. I would first list end positions. So here are some end positions. We have x is equal to 0. That start position is -2. We have x at the position at 3. That, I mean, we got from the table up here, right? That was -10. We have one that we're missing, so x of 5, that other critical value. And we'll recalculate that. It was -2 -8 plus 3. So -8 plus 3. What is that? -2 minus 8 is -10, plus 3 is -7. Good. What about the position, lowercase x, position at 6? We calculated that in our table, and we got -9. Perfect. Okay, so check this out. -8 is between -2 and -10. -8 is between -10 and -7. -8 is in between -7 and -9. Literally, -8 is in between all of these 4 things. So there's 3 in betweens. So the answer is 3. The way that you explain it is something like the particle is at position. I can't spell position. Help me, word. Position. X equals -8. In between each of the above values for a total number of 3. Cool. Weird space there. Nice. Part C. On that interval between 2 and 3, is the speed of the particle increasing or decreasing? All right, so before we even look at the graph, just a reminder of what speed is. You're analyzing velocity and acceleration. If they have the same sign, you're increasing speed. If they have opposite signs, no matter what they are, one positive, one negative, one negative, one positive, it is going to be decreasing. So let's look. Between 2 and 3 is happening right here. And we can clearly see on that interval, velocity on a graph of velocity is height. This height here is negative, which means we have a negative velocity. Now let's take a look at the derivative, acceleration. The derivative or acceleration on a graph of velocity is slope. What is the slope of this interval? On this whole interval, that slope is positive. So notice one was negative, one was positive, opposite signs, the speed is decreasing. And that's exactly what I'll say. I'll say speed is decreasing. Why? Because the velocity of t, I can't type, is less than 0. It was negative, right, below the t-axis. And we can say acceleration of t is greater than 0. On that interval, I guess, if I'm being specific. D. During what time intervals, if any, is the acceleration of the particle negative? Oh, well, I mean, we kind of already answered that, right? We knew that the acceleration is positive, so we know acceleration, we're really just looking for a negative value. We know what we're doing. Okay, so negative slope between 0 and 1. Oh, and this is kind of where we're using this information, right? We have horizontal tangents at t is equal to 1 and t is equal to 4, which means that is indeed exactly where that negative slope stops. Same thing up here, the negative slope begins at 4 because that is when we have a horizontal tangent. And then it goes from 4 to 6. So our answer is 0 to 1, that interval, and the other interval is 4 to 6. Done. Let's write it down. We'll say acceleration is negative on the interval from 0 to 1, 1, and 4 to 6. Forgot a parenthesis. There it goes. I guess it says justify your answer, so we'll say something like because a is equal to v prime, which is negative on those intervals. I don't know if that's over-explaining it. Like, it needs to be negative. It asks for negative, right? No, that's what I would have written. Anyway, let's move on to number 13. Cool, yeah, we're just taking the derivative of, we're putting in natural. This is a little bit tricky. What were the stats for number 13? I can open those up. Whoa, don't look at that. We have this, number 13. Stats, 1 out of 3 of us got it correct, and that is actually the average score is 33%, so we're right on average. How do you solve this, and how do I even annotate this? I have no room. Let me like insert a text box. Is that gonna work? Here's where I can type. I bet I'm in like weird font. Yeah, cool. I'm gonna copy this so I can have it for next time. All right. So first of all, what it's really asking for is everywhere that you see an x, what used to be here is an x, everywhere that you see an x, put a natural log of x. So we're really taking the derivative of the following function. We're taking the derivative of natural log of x, that quantity squared, plus 2x, but instead of x, it's natural log of x. That's what we're trying to do. We're trying to take the derivative, so d dx of that thing. So how do we do that? Well, you kind of distribute the derivative, right? You first take the derivative of this piece, deal with it, blah, 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 and then, okay, now you can take the derivative of that piece. So let's deal with this first one. First is powerhouse. This 2 is on the most outside house, so the 2 is going to come down in front, and then rewrite the inner. The inner is still natural log of x. And it went to the power of 1, which it didn't have to write, but there it is. So that was doubter. That is going to be multiplied by c dot. That's going to be multiplied by dinner. The derivative of the inner, and the derivative of the inner is 1 over x. Perfect. We are done taking the derivative of that left piece. Now we're going to do plus the derivative of the right piece. So again, we don't have any like doubter powerhouse that we had last time because there is no power here. So it's just straight up plus 2 and then the derivative of natural log, which is, I guess I'll do c dot times 1 over x. And there it is. Can we, that doesn't look like these forms. I'm noticing that we probably could get a common denominator of x. How do we do that? So this is going to be, in the numerator, I have 2 natural log of x plus 2, and then all of that stuff, if I put parentheses here, all of that stuff divided by x. Is that an answer? Oh, that's A. Okay, correct answer is A. Can I annotate? I'm just going to highlight it because I don't know what to do. There it is. A is the answer. I'm also kind of annoyed that there's like an outline around that, so I'm going to take that off. All right, number 14. We have a table. Polynomial has selected values of the second derivative. Interesting. Which of the following statements must be true? What are the stats for number 14? 41.7% of us got it on average in the past 4 years. 1 out of 3 of you girls got it correct. Must be true. All right. Well, f increasing does not make any sense because that deals with the first derivative, and we're only given the second derivative. So do I have some sort of shortcut key to do a cross out? If I can't do it in 10 seconds, I'm going to get rid of it. Where's edit font help font? Where was it? Oh, format font. Oh, Command D. I'll remember that. Is my 10 seconds up? It's my computer. If it didn't have this spinning wheel of death, I would have gotten it in time. It's probably just like one button. Yeah, strike through. Boom. So like these, that doesn't happen. You're not allowed to do that. Maximum. Well, again, maximum means that f prime has gone from a positive to a negative, and it's still talking about f prime, so you're not allowed to talk about that one. Inflection point and concavity we are allowed to talk about because that's the second derivative. And just make sure, yeah, must be true. This is correct. So it's between D and E because we know that's the second derivative test. All of these were the first derivative test. So how do we do this? It has a point of inflection. Again, an inflection point is an f double prime sign change. And it says at x is equal to 1. Maybe. What if like 1.5 or like 1.1 went back up to a positive 1 value? We don't know. I mean, plain devil's advocate, we don't know that it does go to a negative. I mean, eventually does, but not immediately. What if it went back up to a positive immediately, right? That's not an inflection point. So that's not a must be. That's a might be. What about E? The graph of f changes concavity on the interval from 0 to 2. Well, it definitely does. Like, look at that. 0 to 2 is all three of these values. Does it change concavity? The definition of concavity is really easy. It's just f double prime. Is it bigger than 0 or less than 0? Look, one's positive, one's negative. I would say that's a change of signs. So the correct answer here is E. Number 15. All right. Just antiderivative straight up. Oh, but the problem is, how do we do this? Where does taxman happen, right? So I cannot put a drawing into an equation. Where is not an equation? Is out here not an equation? Where'd it go? I hit paste. Isn't the last thing I copied this thing? If I click here, paste. I've hit paste like 5 times. I'm getting like a bunch of random text boxes somewhere. Whatever. I'm just gonna insert a new one. Thought I was being fancy by copying and pasting. Anyway, so I'm thinking here that my u, no, I want to do u is equal to, let's do it this way first. Let's look at the integral of x times x squared squared minus 4 to the power of -1. That's kind of how I'm rewriting this function. And then now it's pretty clear to say, okay, my u is this gross thing, this x squared minus 4. Hopefully that will cancel out. Let's see. So if I do that, I will say my u is my x squared minus 4, my taxman. I hope that's okay. Yeah, that's fine. My taxman is x, and my u prime is going to be the derivative of that. It's going to be 2x. So the rate that I'm going to pay taxman, so I have to just type it down here. Pay taxman. I can't handle that font. I'm sorry. Pay taxman 1/2. X divided by 2x is 1/2. So that means our new integral, I'll come back up here, it looks like this. It's going to be the integral of the x turns into a 1/2. Don't know what happened there. 1/2. What is going on? Integral of 1/2. I just want to put a 1/2 in here. Thank you. 1/2. And then all this stuff is just still x to the power of 2 minus 4 to the power of -1. All right, we're ready to take the antiderivative. So that 1/2 is still going to be there. It's not going to give me trouble this time. And from here, I need to do the antiderivative of something to the power of -1. And let me pretend to fall into the trap. Oh, I think it's going to be x to the power of 2 minus 4 to the power of 0 divided by 0. And oh, yeah, that's a problem. You can't divide by 0. So we have a special trick for this. And that is, oh, you're supposed to use the natural log, right? So natural log of the following thing. And that's just x to the power of 2 minus 4. And don't forget plus C, capital C. What do we got? Whoa, some really weird ones, but that's the only one that matched us exactly. So correct answer here, C. Cool. Number 16. Sine of xy is equal to x, then dy dx is equal to what? All right, so just go ahead and take the derivative here. It shouldn't be too hard. Space this. I can't put it in too quick. I want to copy paste this. It will make this work. Paste. Haha, watch that. Mr. Sandell's learning. All right. So for this one, just take the derivative. I don't think there's anything that we can do to make this easier on ourselves. We just gotta rip off that band-aid. So derivative of sine, S stands for same, so same sign. It's going to be cosine. There we go. Cosine of xy. Okay, that was doubter, and now we need to C dot to times the dinner. What is the dinner? The dinner is product rule. It is one of those things that is on our speed sheet, but again, if you don't remember how to do it, it's 1d2, so 1 d2 xy prime plus, and by the way, all this stuff is in parentheses because this is all dinner, plus 2d1 y times 1, and there is the derivative of the left side. Here's the derivative of the right side. Nice and easy. All right, and we're just supposed to solve for our y prime. I mean, this thing is saying y prime in a fancier notation. So what do we do? Well, first we got to divide both sides by cosine xy. So after doing that, we get an xy prime plus y is equal to 1 over all this stuff, this cosine of xy. Cool. Next, we got to subtract a y. So I get an xy prime. No, I want to be an equation. Xy prime is equal to all of that junk over here, cosine of xy minus y. Ooh, check this out. They don't have any like minus y, so I have to have like fractions or like denominators here. So what do I got to do? I need to multiply the top and the bottom, the numerator and denominator, by cosine xy. It's a little bit annoying, but it happens. And multiply the bottom by cosine of xy. There we go. And then finally, we're going to divide everything by x. So if I do that, I'm left with a y prime. And on the right-hand side, I'm going to have a fraction. The numerator is going to be this 1 minus y cosine of xy. The denominator should be like terms, right? Cosine of xy, x lowercase y. But then we divide everything by x, so I can just slap on an x right there. I would like it to be like a variable type of thing. Will it let me to, okay, can I slap one right there? Sure. It looks more like a variable. Cool, we're looking for that. And that is D, like exactly D. Just double checking. I'm not making a silly mistake. Looks good. Yep, D. I haven't looked at the stats for number, I don't even remember last one I looked at stats, to be honest. Oh, my cursor says I last looked at 14. Let's look at 15. 15, average score of 75%. Only 1 out of 3 of us got it correct, though. And number 16, none of us got it correct. I guess this is the hardest multiple choice problem on the packet. Yeah, 29% average, none of us got it correct. That one was a hard one. I think it probably came from maybe taking the derivative correctly, forgetting about dinner. That would be my guess. Maybe my other guess would not know that you had to multiply the top and bottom here by cosine xy to get like denominators. The reason I knew to do that was because they didn't have two fractions. This was all one fraction. So somehow you have to have like denominators to convert two fractions into one fraction. Anyway, you should now obviously pause the video and do these on your own, and then check yourself after you do these problems. All right, well, I'm gonna try to do this while you guys are working. Just kidding, you unpause the video and you're checking your answers right now. This is in the future, hopefully by 10 minutes or so, we'll see. The slope of the line tangent of the graph. So whenever I see these words, slope of the line tangent, that means just y prime. That's a fancy way of saying, hey, we're after a y prime. And it's confusing because you see, oh, line tangent to the graph. Like all of that stuff sounds like a y minus box equals to, m box times x minus box in the point slope form. No, it's only looking for the slope of that. So only the y prime. So we're after the y prime. And we have a natural log of x, but we're plugging in e squared. So what we really have for y is natural log of, let me type in the old one, x to the power of 2. There's the old one. But in the place of x, this x has now turned into, parentheses, e to the power of 2. So we're trying to take the derivative of that, and something is wrong, because that's just a number. Oh, wait. Yes, I'm very silly. Hold on. I am super sorry. That is correct. That I don't plug this in until you take the derivative. I'm so sorry. Do not plug this in immediately, because that is just a number. The derivative is 0. That's not an answer. Anywho, maybe we can just edit that out. No, I'll leave it in. I make mistakes. See, Mr. Snell is human. Y prime is equal to, let's do Doubter. Doubter is going to be 1 over whatever, y prime is equal to 1 over whatever the inner was, which is x squared. All right, that was Doubter. And let's multiply it by the dinner. The dinner is just 2x. Beautiful. Simplify. Y prime is equal to 2x on the top, 2x. I meant to type in a 2x over this x to the power of 2, which is going to be equal to 2 over x, and that is nice. Okay, so done. We simplified. Now plug in e squared, and it's going to be 2 over e squared. B. All right. What about number 2? Ooh, a graph. We got a graph of f prime. Let's read. Graph of f prime, the derivative is shown above. The domain is between 0 and d. Okay, so far so good. Which of the following statements is true? Okay, and they're not trying to do like a double negative or anything. So true, important to know. F has a local minimum at x is equal to c. Okay, the definition of minimum, as a reminder, is when we have an f prime go from a negative to positive, and vice versa down here. This is going to be, let's just do it like this. We have an f prime that goes from the other way, positive to a negative. Yay, typing correctly. And is that true? Well, let's see. At C, I'm going from a positive height to a negative height. The opposite of what it's looking for. What about B? B is positive to a positive height. Like on f prime, this is a graph of f prime. On a graph of f prime is height. So the height here goes between a positive to a positive. It never switches signs because it never even gets close to the x-axis. That makes no sense for B. What about C? The graph of f has a point of inflection at a comma f of a. So remember that the definition of an inflection point is, I'll type it down here. Inflection point is whenever you have an f double prime sign change. And on a graph of f prime, what is f double prime? Slope. So it's really saying here a slope sign change at a. Look at that spot. Does that look like it changed its slope? No. It's positive, 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 until you hit here, and then you go down. So it does have an inflection point at B. Oh, cool. Well, there's the answer then. E. I still want to analyze it, right? The graph of f is concave up on CD. Well, that's the opposite of true, right? So this slope here is sloping down. So we have a negative slope. Negative slope means negative f double prime. So we have a concave down between C and D. Cool. All right. Number 3, we're trying to do the definite integral of that thing, which looks kind of scary if I'm going to be honest. Let's go ahead and copy paste this text box so I don't have to recreate everything. Paste it down here. Don't hide the calculator. There we go. Okay. And I deleted the whole box. There we go. Well, let's rewrite this first. So this is going to be the integral between. Wait a sec. Is it really from 2 to 1? That's backwards. Okay, so we need to have some weird negative thing happening here. Let's keep that in mind. Anyway, we have x plus 1. That has to be correct, right? Okay, times x squared plus 2x, all that to the power of negative 1 dx, if we're being formal about it. We don't need to be formal. It's multiple choice, Mr. Simmel. All right, what do we do from here? From here, we need to choose who is our u. I'm going to choose the most complicated inner part, which is going to be this x squared plus 2x. We need to choose a taxman, who happens to be that gross x plus 1 value. Plus 1 value there, and then we need a u prime, and that's going to be equal to 2x plus 2. Hey, check this out. Factor out of 2. 2 times the quantity of x plus 1. That means when I'm paying taxman, this x plus 1 and x plus 1 value are going to cancel out, and I'm going to be, I'm going to pay the taxman this cool rate of 1/2. Cool. So what does that mean? Let's not be. What? I just wanted to not be formal. Go. I just want the dx to die, please. Okay, thank you. Okay, so that means our new integral. Can I make this negative and have these bounds correct? Yes, let's do it. Okay, so it's going to be the integral and make these bounds actually make sense from 1 to 2. And then I paid this x plus 1 with 1/2, and I'm going to have this x squared plus 2x, still to the power of negative 1. I'm not going to fall into the trap because I've already done that in this video. If I take the antiderivative of this, I would divide by 0, so it must be a natural log. So this is going to be equal to negative, is still out there, right? Negative natural log of absolute value of this thing, this x squared plus 2x. We don't have a c, we have an evaluation bar. I don't know how to do that on here. How do I do an evaluation bar? It's between 1 and 2. I'm going to be lazy. Between 1 and 2. I don't know how to do it. I've never done that before, and it's going to take me too long to learn. So I need to now have some room to do that. So plugging in those things, and what are we going to get? So first we're going to we're going to do the end value. We're going to plug in this 2 first into all of those x's. So what are we going to get? We're going to get that negative. It's going to be factored out at the very least. Don't worry about that until the very end. And we have natural log of absolute value of this 1 squared, which is 1, plus 2 times 1, which is 2. So natural log of 3. It's easy. And then minus, we have the natural log of absolute value of something else. That natural log, now let's plug in 2. Wait. I'm so sorry. We plugged that in backwards. Sorry. I'm sorry. That goes here. We're supposed to first plug in 2. When we plug in 2, we're going to get 4, because that's 2 squared, plus 4, because that's 2 times 4. Or 2 times 2. My God. It's not that late. It's only like 11:10. Perfect. And somehow I'm trying to aim for one of these forms. What do I got up my sleeve? Well, first I can simplify. So I'll have a negative natural log of 8 minus a... I can distribute the negative. Yeah? Are you ready for this? Distributed. That's a negative. This is now a positive. Natural log of 3. Ooh. This is looking pretty nice. Oh my God, Mr. Sindel. I feel embarrassed. That is the right answer. Do you see our mistake? Pause the video now. Find the mistake. Get some extra credit, please. We didn't pay tax man. Well, we did, but we forgot about him. You can't just forget about paying the tax man. The IRS is going to come for you. There we go. Now we have the 1/2, which means all this stuff. I'm going to put the 1/2 right there and pretend I never forgot about it. Distribute the 1/2, which means it's this whole thing. Quantity divided by 2. Oh, look at that. It looks pretty good. Except it's backwards. Maybe the bounds were supposed to be between 1 and 2, and I made a mistake on them, because, yeah, they're definitely backwards. It means you have to make them negative. Yeah, I'm going to go fix this for next year, or if you found a mistake and I'm just doing something really silly, please let me know tomorrow on Friday. But I'm pretty sure that should have been the right answer. I think what I'm going to do for next year is I'm going to change that to a 1 and a 2. But I'll leave it like that for now. That's what our original problem was. Onward. Wait, I didn't circle what in theory should have been the right answer. Highlight what in theory was the right answer. On to 4. All right. I didn't mean to move you away. You can stay right there. Do I have enough room for you? Let's put you right there. Okay. Oh yeah. Blah blah blah. We're trying to find y prime. Take the derivative. Essentially. Oh my God. Do we really have to do something like that? I hope that's not the answer. That's going to be painful. Here we go. Take the derivative of tangent. That's secant squared. So here we go. Secant squared of whatever the inside is, xy. We're not going to do dinner yet. That was just doubter. Cool. Doubter's done. Let's multiply that by dinner. Dinner is going to be the product rule, 1d2. So it's going to be 1d2. Again, all of this stuff is dinner, so have it in parentheses. Plus 2d1, which is just going to be y times 1. And that is the left side. Right side is equal to 1. All right, we've taken the derivative. We've got to isolate that y prime. I don't think we're getting anything that gross. This is looking pretty nice so far. What do we got? Let's move all this junk over, right? Let's divide both sides by secant squared xy. So I just have on the left-hand side this xy prime plus y. On the right-hand side, I have a fraction, this 1 divided by the secant squared of xy. Nope. Good, okay. Let's subtract a y, and now we're going to get gross. Is there any way around this? Kind of, actually. Because I'm noticing they're having cosine in their answer, because the definition of secant squared is 1 over cosine squared. So I'm having a feeling, okay, let me change this right from the get-go. So let me rewrite this. This is xy prime plus y is equal to cosine squared of xy. This is one of those definitions that I haven't talked about very much, but secant squared is the, not inverse, it's the reciprocal, there you go, the reciprocal of cosine squared. Just like secant is the reciprocal of cosine, cosecant is the reciprocal of sine. Do I need to write those down somewhere? Probably. let's, you know, go like that, go like this. Here are some rules that you should memorize. First, there you go. 1 over cosine, well, let's do sine, let's like the common one. 1 over sine of x, sure, thank you, is equal to cosecant of x. Cool, the more you know. 1 over, I did sine cosine of x is equal to secant of x. And yeah, you gotta have all three of them, right? 1 over, why is my typing so bad right now? Tangent of x. Why does that look so weird? I just want to type tangent there of x. I'm gonna be super nitpicky. I don't need to be. I want the parentheses. I hate when other mathematicians don't have parentheses. Is equal to cotangent of x. Cool, you have all those definitions down. Boom, boom, boom. Yeah, remember that. Anyway, cool, we use that definition. Let's keep going. We're going to subtract y from both sides. Y, xy prime is equal to cosine squared. That's a little bit too big. Cosine squared of xy minus y. We're getting closer and closer to that form E, and I'm pretty sure that's the right answer. Just divide by x, right? So we get this y prime is equal to, yeah, this is me feeling the time. I want to go to bed. And that all is divided by x. You don't need to write it because your AP calculus class is smart, but they still want to see a nice key. Like that song? All right. Hey, look, it's the exact same as E, like we predicted. Not the beginning, but like towards the end. Cool, cool. All right. Well, aside from that weird error that happened in number 3, that's the whole thing. And stay tuned because I want to see what happened from last year. What's the key say from 3-4? 3-4, what do we do for the key? Down, down, down here. Awesome, didn't do it. Well, I didn't even catch that error last year then. Good job, Mr. Sindel. I will reconvene with you girls on Friday to make sure that that is indeed an error, but it just feels like it to me. Thanks for watching. That was a long video, and I will see you girls on Friday.